Welcome to School of Civil Engineering. The series of SDSM software analysis we have started about is a procedure that how can we predict our future climatic condition by analyzing climatic parameters. In my first video, I have discussed about SDSM software, that how can you download and from where you can download the main original or free version, and how can you install that. And in my second lecture, I have discussed about that how we can process data as SDSM accepts some specific data. So I have discussed about that how can we process data for SDSM chapter, and from where we'll get the data, and how to download predictor data, predictor variable data from website, and every link I have provided there. And third video, I have discussed about rainfall analysis. I mean, using our past rainfall data, past 15 year rainfall data, we have predict about future rainfall condition. I mean, what will be the change, or how will increase or decrease the temperature condition in our future. And in this video, I will discuss about temperature analysis. So in temperature analysis, for maximum and minimum temperature, the both procedure are same. So I will discuss it in this video. In one video I will cover that, and as I have discussed briefly in my past video about the procedure of analysis, so I will go through quickly in this video. And if you have any confusion, or if you have any problem about this series, so you can comment me below. And you can also see the past video, I mean the previous video, to understand everything. So let's start. In my previous video, I have show you that how can we process this data, and here I have take every data in one folder. And why we have take every data in one folder, I have discussed in my past video. So from here there has the maximum temperature and minimum temperature of Chittagong zone, and there is our predictor variables data. So by using that, I'm going to delete that as it is. Okay, no need. So by using that, we can predict our future condition of temperature, or maximum temperature or minimum temperature. And I have shown you that how can we process that data. You can check my first video. Let's start. Here at first we have to start SDSM software, and then we have to change some setting. We have to go setting, and then we have to select here 366 and one thing for rainfall temperature. So for a rainfall condition, we have seen that here event threshold will be 1, and but for temperature analysis it will be 0. And here we have to change our date 01. It's our analysis date, I mean the data which we have collected from our meteorological department. And here we'll select on YouTube, or it will be default like as, and save. Okay, and advance. From here we have to change for temperature it will be none, model transformation it will be none, and here optimization algorithm will be dual simple X, and everything will be as like as default. Save. Okay, back, and our setting is complete, then we have to go quality control. I mean, we'll take our file. Okay, we are going to work about maximum temperature, so let's take it open. There have the number of data is 5478, so it's okay. That what is that? It is the total number of day for our analysis period. Okay. Then we have to go skin variable. In skin variable, we have to at first we have to select the predicted file maximum temperature Statistical, and then the date will be as select analysis period will be annual, and from here processes will be unconditional, it will be untick, and from here we have to go to box or predicted file box, and from here we have to select first 11 variable and 2 3 4 5 6 7 8 9 11. So first 11, then we have to click here analysis back, then we have to click correlation and from here we have to select where p value will be minimum or 0 and partial r will be maximum, or partial value will be maximum and p value will be minimum or 0. So from here we're seeing that there are several value of 0. First of all, here we have p value 0, here also p value 0, we have p 0 0 0 0 0. So we'll select two value where p is p value 0 and partial maximum. So here we're seeing that it's 0.09 at 0.6 and here 0.105. We're seeing that ncpp5 vgl dot here there have here we're seeing that ncpp5 vgl dot here p value is 0 and partial r is 0.105 is the most biggest value of partial, and second here we can find another 0.099, it is the second biggest. So we'll note it somewhere ncpp cpp1 ugl and another value is ncpp5 vgl dot and go back. You have to note this data where p value is 0 or minimum and partial r is maximum, and go back again and then select next 11 data. And I told you in my past video that predictor variables have only 26 variables. So from here at first we have select 11 and then we will select next 11 data. From here there is the next 11, so again do the same work, analyze, go back and correlation. Here also we're seeing that they have 1 2 3 4 5 6 7 p value 0. So from here we have to find the maximum partial, p value will be 0 or minimum and partial r will be maximum. So in first data we are seeing that p value are 0 and partial r are 0.364, and for next is minus, for next it's also 0.136 0.139, and for here this partial 0 value p0 value it's minus. So we'll take that NCCP 8 visual. First, the first value NCEPP500GL, and second NCCEPP 8VGL, and we have taken our 4 data, and next for our next value we have to select next 4. Let me uncheck it, and here is the next 4. First 11, second 11, 22, and it's for 26. So we have to again analyze back and correlation. From here we have to find any one data where p-value is 0 and partial r is maximum. So from here p-value in 4 data, p-value are 0, partial or maximum, and last value 0.661. so we'll write it NCEPP TEMPGL. okay, we have got our 5 data, and then we'll select only those 5 data: 8 VGL, NCEPP 50GL, here is another, and there have one NCCP 5 VGL, and here NCCP 1 UGL. We have selected our 5 data. We have get from correlation, and then we have to again analyze them. These 5 data we have to analyze and correlation. From here we have to select final 2 data where p-value will be 0 or minimum and partial r will be maximum. So from as the first 2 data p-value are not 0, so we'll go for next. Here p-value are 0 for next 3. If there have any value of p-value, there have no 0 value, so we is to select the minimum value. So we'll go for last 3, and here we're seeing that the last value showing maximum partial r, and another 2 are showing that 0.067, 0.066. so here showing that the middle data or last data are showing that the partial maximum and p minimum. First of all we have to select p value minimum, then from those minimum value we have to find the partial r maximum. So here you are seeing the 0.028. here this value is more than 0.006, but we're selecting that because p value are 0 here or minimum. So we'll select these 2 data. We're going to write it again: NCCP 500GL and NCCP TEMPGL. So again we have to select those 2 data, here 1 and here 1. So we have selected 2 data, and again go analysis and correlation. Okay, our skip variable work is done. Then we have to go for calibrate model here, calibrate model, and again we have to select our t maximum predicted data, and we have to select the output par file, where by using this par file we'll do our next work. So here is the, we'll select it in cycle temperature file. We'll give a num tmax Chittagong. Save. It will be saved in the name of tmax.par. Our this date will be same as, and here The process will be unconditional. It is the monthly include calculate. We have to tick it here, and everything will be default like as. And again we have to go to our prediction box, and we have to select the two predictor variables we have finally taken. The one was NCPP, 500L, they have one, and another was here NCPP MGL. There we have two data. Then we have to calibrate it. It's done. Our calibrate model is also done. Then we have to go scenario generator. So from scenario generator we'll select the par file from previous. Here the par file from our previous analysis. Open, and here we have to select, before that we have to change our setting. From 3600 we have to set GCM 365, and everything will be okay. Back, and from here we have to select input as par file. I mean from calibrate model we have taken that, and we have to go to the box folder, and we have to select the can ESM2 historical. Double click here, so you can see that. Double click here, and we have to save this file as out file. So we'll save it tmax here, tmax, sorry, tmax Chittagong. You can give any name, but I'm giving this name, tmax Chittagong. Open. So our work is done. Then go to yes, then okay, our out file is ready. Then we have to go summary statistics. From here we'll get our main data. At first we have to select models. The date will be same as like us. We have to select the out file, tmax. Here is the out file. We have to select out file from here, and we have to select the text file, I mean our output file. Select output file, it will be in text format. So maximum temperature, tmax. As we're doing that for model, modal, we'll give it is tmax Chittagong model. Open. As we're doing it for data source model, so we have to analyze that. Our model file is ready. Again we have to select observed file, and we have to then the selected input file will be same as, and output file we have to change the name. Here we have got the text file, model file. We'll give it observed, OBS, observed file. Open. Again analyze. Then we'll go back and go for compare result. Here we have to select those two files. First of all model file, let's select, and then select observed file. Here in rainfall analysis we have to select sum, but for temperature analysis we have to select main. This is the most important thing. In maximum or minimum temperature we have to select main for both, and for rainfall we have to select sum. So main and C in bar. Here is our data, the model data showing that in January, February, and January, February, March, and here November, December, the here rainfall will be very low, cause in Bangladesh in this season is known as winter season, and here in January February the rainfall will be maximum cause it's known as summer season. So copy it from here and go to copy it back, minus it, and go to SDSM folder here, next it again, and here we have to paste this data in Excel file. So open an Excel file and open it, paste your data here. There is a data, a model data and observed data. We don't need any observed data for analysis, we need model data. By using model data we'll analyze our, or we'll compare our further data. So it's going to delete that observed data, we'll delete that, and it will be same as, okay, save as. I have told you in my future video they have CPR 45 and CPR 8.5, so we'll do that for both files. So first of all CPR 4.5 will make a datasheet for it, and again we'll add another 4.5, sorry 8.5, 8.5, okay, we'll copy it for 8.5 as the both file is same, both file is same, so we'll do that here. Now one thing for 8.5 4.5 the model data will be same for the observed data. I mean by using which data we are doing that, it will be same for model and also for, and in my previous video I have show you how we'll do for RCP 4.5 and RCP 8.5 for your future analysis or predict your future temperature condition. So you have to see the previous video for analysis your future data, and I think that will be helpful for you. And you don't understand, please you let me know, I'll try to solve it again. Thank you very much. Stay well, stay connected.